This is First Coast Math Clinic with Lesson 1, Classifying Polynomials, from Unit 12, Polynomials, from our Pre-algebra and Algebra curriculum. So the goal in this video is to classify polynomials by terms and by degrees. And before we get into classifying, I want to actually define what a polynomial is. So polynomial is a mathematical expression consisting of terms and operations. So if we break up that word, polynomial basically literally means many terms. So the poly means many and the nomial means terms. Let's go through some expressions that are polynomials and some that are not. So our polynomials, we have something like expression like 2x to the second plus 3x minus 4, or negative 4x. 8 is a constant, and negative 10 is a constant as well. So if we're looking at just the terms, so the 2x squared is a term, 3x is a term, and the minus 4 is a term. So each one of these is a separate term. Now, some of the expressions that are not polynomials, 2x to the negative third minus 5. Now, this is not a polynomial because the power on that exponent is negative. 2 over x minus 5 is not a polynomial because we're dividing by the variable, so that's not a polynomial. And 4y to the 1/3, because our exponent here is a fraction, that's not going to be a polynomial as well. All right, so we're going to be working specifically with our examples that are polynomials in this video, and we're going to classify them by term and by degree. So let's get into some examples of terms and degrees. So when we classify polynomials, there's two ways we can classify our polynomials. The first way is by degree. And when we classify by degree, we're looking for the highest power on the variable. So let's look at a couple examples. Let's say we have just a constant 7. Well, we don't have any variable here, right? So, well, what can we do here? Well, we can actually write in a variable and write in x. And if we don't have a variable, we can make that x to the 0 power, because I know anything to the 0 power is going to be just 1. So if I have x to the 0 power, just a number by itself, this is going to be a constant. So if our power is 0, that's a constant. If I have something like this, 3x minus 3, well, what's our power here? It's 1. That's going to be linear. So if our power is 1, it's linear. If we have something like this, 3x squared plus 4x minus 5, well, our power here is 2. Our power on this x is 1. So we want the highest exponent. So we're going to look at this 2, and that's going to be quadratic. And if we have something like this, 12x to the third plus 3x squared, well, we're comparing our powers here. So we've got 3 and 2. Well, what's our highest power? Highest power is 3, and that's cubic. So if our highest power is 0, so basically just a number by itself, so we have like 7 or negative 4 or 10, that's a constant. If our highest power is 1, it's linear, 2 is quadratic, and 3 is cubic. Now, if we want to classify by term, that's basically just the number of terms that we have in our expression. So if I have something like this, 4x, we've got just one term by itself, so that's a monomial. Something like this, 5x squared plus x, so our terms are separated by our operations plus and minus. So here we have two terms, 5x squared, and the x, so this is a binomial, so let's think of our prefix. Mono is 1, bi is 2. Something like this, 7x squared minus 9x plus 1, so we've got 1, 2, 3, so this is going to be a trinomial. And typically any higher than 3, we can just reference as a polynomial, okay? So let's get into a couple examples where we classify our polynomials by degrees and by terms. So for number 1, we've got negative 4x to the second plus 6x minus 7. So we've got 3 terms. Highest exponent is 2. So this is going to be a quadratic, trinomial, quadratic because it has a power of 2, and trinomial because we have 3 terms. Number 2, let's start with the number of terms, right? We've got 1, 2 terms. So it's, actually, let's start with the exponent, right? Like highest power is 3, so it's cubic. And then the number of terms, we've got 2 terms, so it's a binomial. And number 3, the highest power is 3. So again, that's cubic. And then the number of terms, we've got 1, 2, 3, 4. Any higher than 3, we could just refer to it as a polynomial, so a cubic polynomial. So for 4 through 6, I want to find the degree of the polynomial. And my degree is going to be the largest sum of the exponents. On the variables. So to find my degree, I want to sum up the exponents that are on my variables and take the largest one. So let's start here. So my values, my exponents are 2 and 3. So I've got 5. My exponents here are 9 and 4. I get 13. So my degree is going to be the largest sum, which is 13. So my degree should be 13 for number 4. Number 5, I've got 2x y to the 5th. My exponent here is 1, so this is going to be 1 plus 5, which is 6. For the second set of terms, this is 7x to the 4th, y to the 1st, so this is 4 plus 1, which is 5. For the third set of terms, here, this is 3x to the 3rd, y to the 4th, so this is going to be 3 plus 4, which is 7, so our highest sum is going to be 7, so our degree is going to be 7. And then for number 6, we've got just 9 here, so what would our variable be if I put my variable in? That's just going to be x to the 0 power. For the next set, 8x to the 3rd, z to the 5th, so it's going to be 3 plus 5, which is 8. And then for the last one, 2x to the 2nd, z to the 4th, it's going to be 2 plus 4, which is 6. So I've got 0, 8, and 6. Largest sum is going to be 8, so my degree is going to be 8. All right, so this was lesson 1, classifying polynomials. We classified polynomials by degree and by term, and then found the degree of polynomials with multiple degrees. So we had to kind of sum up the exponents and find the largest degree. Hope this video is helping you guys. If you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.